this video, I'm going to show you 4 more examples of how to factor by grouping. Now in the previous video, I showed you some steps for factoring by grouping, and what you want to do is look for, in the first 2 terms, a GCF, and you're going to pull that out. In the second 2 terms, pull out a GCF, and then what you want is to have factors that remain that are exactly identical. But what I didn't mention is that before you even start your problem, what you should look for is a GCF from the very beginning. So before you even start your problem, you should always look for a GCF first. And this is really going to help you out. So what I mean by that is, from the 4x, the 8x cubed, the 12x squared, and the negative 24x, I notice how all of these terms are divisible by the number 4, and all of these terms can have a GCF taken out. And so this is the GCF of all the terms. And so what I'm going to do before I do my grouping is notice that I can take that GCF out from everything before I do my grouping. And so every term divided by 4x squared would be like this. So I'm going to take that out. 4x, if I take the 4 out, x to the 4th, take away 1x, I'm left with x to the 3rd. 8 divided by 4 is 2. If I take one of the x's away, I'm left with a square. 12 divided by 4 is a 3. X squared, take away an x, I'm left with an x. And then 24 divided by 4 is 6. We took the x out, and so that's going to be the polynomial that remains. Now what I want to do is find, like I did in the grouping beforehand, the GCF of these 2 terms. And so this, between x cubed and x squared, I'm going to take out an x squared. And so I'm going to leave the 4x outside for the front. I'm just going to kind of ignore that for just a minute. And so if I take an x squared out of these 2 terms, I'm left with an x and a minus 2. And then between my 3x and my 6, a GCF here would be the number 3. And when these 2 match exactly, that means that's going to be one of my factor pairs. So my x minus 2. The GCFs are going to come together to make the other factor pair. And then the GCF that we had in the very beginning will also just land in the front of your polynomials. You can write it in parentheses, but you don't have to. And so that could be an option if you want to write it in parentheses, you could, but really it won't matter. Okay, now I'm going to do the same thing over here, and I'm going to notice here, before I start, is there anything I can take out of every single term? Are they all divisible by a number and a letter? And in that case, all of these terms are divisible by 3 and the letter x. So this is your GCF of all the terms. So I'm going to take that GCF out front first. Now I'm going to divide from all 4 terms the GCF that they all shared. So 6 divided by 3 is 2. X to the 4th, take 1 away, I'm left with x cubed. And then my next term here, 9 divided by 3 is 3. An x cubed, take away an x, is an x squared. 12 divided by 3 is 4. An x squared, take away an x, is 1x. 18 divided by 3 is 6. And x, take away the x, I have nothing left over there. Now I'm going to just kind of ignore that GCF out in the front, and I'm going to do grouping like I normally had done on the previous video here. So if you haven't watched that video yet, please go back and check out that video before you finish these problems. So the GCF from these 2 terms, I notice how 2 and 3 don't have any number in common besides 1, but I know I can take out some letters from both, and I'm going to take out an x squared. And what's left if I take out 2 x's would be 2x from the first term and the number 3 from the second term. And then again, my GCF of these 2 terms would be the number 2. And then if I take 4 divided by 2, I'm going to be left with 2x. And then 6 divided by 2 is 3. And because these 2 match exactly, that means one of my factor pairs is the GCFs, and because these matched exactly, that's one of my factor pairs. But I can't forget about that GCF that I took out from all of my terms, and I'm going to write that out in the very, very front. So my 3 factors are 3x, an x squared plus 2, and a 2x plus 3. I challenge you, why don't you pause the video and give these next examples a try, and then continue the video to see if you got them correct. So I'm going to look at all of my terms and see if there's any number that I can take out of all of my terms. And each of these numbers, all of them are divisible by the number 4. And I don't have x's to take out from every term, so this polynomial is only going to have a number as its GCF from all the terms. So let's divide all of these numbers by 4. So 2x cubed, 32 divided by 4 would be 8x squared, 28 divided by 4 is 7, and then 112 divided by 4 is 28. So now what I'm going to do is pull out the GCF for my grouping for my 4 terms of the first 2 terms. Both of these terms are divisible by 2, and the smaller power on my letter is a square. And what's left here would be 1x from my first term, and 8 divided by 2 is 4 for the next one. And then in my next 2 terms, the GCF here would be, looks like the number 7. And if I take out that 7, I'm left with the x. 28 divided by 7 is 4. So again, when these match exactly, that's going to be one of your factors. The GCFs that you pulled out from here are the 2x squared and the positive 7. And then don't forget about that GCF that you pulled out originally, the 4, is also going to be one of your factors of your original polynomial. All right, we have one more, and I noticed that all of those for sure are divisible by 5. And I noticed that I can take an x away from every single term. So I'm going to divide out the 5x from every term of that polynomial. So I'm going to be left with an x cubed, an x squared, a 4x, and 4. So now what I'm going to do is look at the first 2 terms of the polynomial that remains and take out the GCF here for my grouping. So x cubed and x squared, the GCF will be the smaller of the power, so x squared. And what I get after I take out 2 x's would be x minus 1. And then in these 2 terms, my GCF would be a positive 4. And then what I'm going to do is divide that out. 4x divided by 4 is just the x. 4 divided by 4 is 1. Now when these match exactly, that's one of your answers. And then the GCFs that you pulled out pool together to make the other binomial. Just don't forget about that GCF that you pulled out right away. And this is your fully factored polynomial by grouping.